So we're given this expression is the Taylor series about 0 for which of the following functions? And they give us some choices here. So let's just think a little bit about this series that they gave us. So if we were to expand it out, let's see, when n is equal to 0, it'd be negative 1 to the 0 power, which is 1, times x to the 0, which is 1, over 0 factorial, which is 1. So it'll be 1 plus, and then when n is 1, well, then this is going to be negative. So it's going to be minus, and then x to the first over 1 factorial over, well, I could just write that as x right over here. And then when n is 2, the negative 1 squared, that's going to be positive, x squared over 2, and then it's going to be minus x to the third over 3 factorial, and then it's going to be plus, and I can keep going. You've seen this before, x to the fourth over 4 factorial. And it's going to keep going, minus plus. It's going to keep alternating on and on and on. Now, our general form for a Taylor series about 0, which we could also call a Maclaurin series, would be, our general form would be f of 0 plus f prime of 0 times x plus f prime prime of 0 times x squared over 2 plus the third derivative at 0 times x to the third over 3 factorial plus the fourth derivative, you get the idea, evaluated at 0 times x to the fourth over 4 factorial, and we would just go on and on and on. Now, to figure out which function, in order what I wrote in blue to be the Maclaurin, or to be the Taylor series about 0, or in order to be the Maclaurin series, that means that f of 0 needs to be equal to 1. It means that f prime of 0, actually let me write this down. It means that f of 0 needs to be equal to 1. F of 0 is equal to 1. It means that f prime of 0 needs to be the coefficient on the x here, which is negative 1. And we could keep going. It means that the second derivative at 0, well, that's going to be the coefficient on this x squared over 2. So that's got to be equal to 1. And you see the general idea that the third derivative at 0 is equal to negative 1. It's the coefficient on the x to the third over 3 factorial, which is negative 1 right over here. And so just using this information, can we figure out which of these it is? So you could do a little bit of deductive reasoning here. Let's evaluate all of these functions at 0 and see which of these are 1. So sine of 0, well, that's 0. Just by looking at this first constraint, sine of 0 isn't 1. We can rule that out. Cosine of 0 is 1, so that's still in the running. E to the 0 is 1. E to the 0 is 1. And then the natural log of 1 plus 0, that's the natural log of 1, which is 0. So that's out of the running. So just from that first constraint, knowing that f of 0 is equal to 1, we're able to rule out 2 of the choices. Then, knowing that the first derivative evaluated at 0 is going to be negative 1. Well, what's the first derivative of cosine of x? Well, it's negative sine of x. If we evaluate that at 0, we're not going to get negative 1. We're going to get 0. So we can rule this out. Now, the first derivative of e to the x is e to the x. If we evaluate that at 0, we're going to get 1, not negative 1. So we can rule that out. And so not even looking at anything else, we have a pretty good sense that D is probably our answer, but we could check. The first derivative here, f prime of x here, is going to be negative e to the negative x. So f prime of 0 is going to be negative e to the 0, or negative 1. So it meets that one. And if you were curious, you could keep going and see that it meets all the other constraints. But choice D is the only one that meets even the first two constraints for the function at 0 and the first derivative at 0.